Good morning, welcome to the Lionheart Academy. This is Trigonometry lesson 36. We're moving forward to the next part of our section, our lessons, in which today we're going to start talking about fundamental relations or fundamental identities. Okay, I think in the newer textbook it's called identities. Now, so the fundamental identities or fundamental relations is basically a set of relationships between the trigonometry functions that we have learned about. Okay, so let's go ahead and see. This is going to be developed into some very interesting topic as well. Now, as you remember, the definition of sine and the basic six functions, sine is y over r. Okay, cosine theta is x over r, or the adjacent over the hypotenuse, and tangent theta is equal to y over x. All right, and cosecant theta, all right, is equal to r over y, and secant theta is equal to r over x, and cotangent theta is equal to x over y. So just by inspecting the basic definition of the functions, we can see they are related to each other. Now, I think I have already mentioned a lot of the reciprocal relationship already, but let's take a look at this. Sine is equal to y over r, cosecant is equal to r over y. So when you multiply them together, guess what? Sine times cosecant is going to be equal to 1, right? So sine times cosecant theta, sine theta times cosecant theta will be equal to y over r times r over y. So basically r and y, and they will cancel each other out. It will be equal to 1. So this kind of relationship is called the reciprocal relations or reciprocal identities. So this is the first thing we were going to talk about. This is very important. It's called reciprocal identities. There are several sets of identities we're going to be talking about today. Reciprocal identities will be the first one. So, because you can see, sine and cosecant are reciprocal. So, what we can do is we can write this: sine theta equal to 1 over cosecant of theta. Because when they multiply each other equal to 1, I can divide cosecant theta on both sides. So I can have sine theta equal to 1 over cosecant theta. By the same token, cosecant theta is 1 over sine theta because they are reciprocals of each other. So when they are reciprocals of each other, the two things are reciprocals of both of the functions. So it's true that both of them are reciprocal. So sine is 1 over cosecant, and cosecant theta is 1 over sine theta. Alright? And cosine theta, as you can see, cosine is x over r, and secant is r over x. So they are reciprocals of each other. So cosine and secants are reciprocals of each other. So if I have cosine, I can write it as 1 over secant. If I have secant, I can write it as 1 over cosine. Okay, that's going to be very, very useful later on when we want to simplify equations. And tangent is y over x, cotangent is x over y, so they are reciprocals of each other. So cotangent and tangent are reciprocals of each other. So we're going to be able to use this to help us simplify trigonometric expressions, help us simplify and solve equations, and do improve identities later on. Okay, so and hopefully this reciprocal identities is quite simple, it's quite straightforward. All right. Now there's another. Let's go back up here a little bit. Alright, take a look at this. Sine is y over r, cosine is x over r, right? Now, you remember tangent is opposite over hypotenuse. Now, excuse me, tangent is opposite over adjacent, which is y over x. So, this is more, maybe it's not as easy to see, but when you do cosine, okay, when you do sine, you remember in certain operations, or in certain situations, when r in the unit circle, right? When r is equal to 1, r is equal to 1, sine is equal to y, right? Sine of the angle is equal to y, and cosine theta equal to x when the radius is 1. So essentially, sine theta or y represents sine theta, and x represents cosine theta. And so tangent theta, when you do y over x, you can actually say that it is sine divided by cosine. Alright, let's see how that works. So sine is y over r. So let's say r is not 1 right now. Cosine is x over r. But when you divide by a fraction, you multiply by its reciprocal, right? So you multiply by the reciprocal of the denominator, which is r over x. So as you can see, the r cancels out, so this becomes y over x. So in this case, the r, because both of them are fractions with the denominators of r, so r actually cancels out when you divide the two fractions. So it becomes y over x, which is the definition of tangent. So tangent has another way to relate to tangent to sine theta. This is also very important. This is called quotient identities, okay? Quotient relations. Okay. Because we are dividing, so it's called quotient identities. The quotient identities is that tangent is the quotient of sine and cosine, and this will come to help us so many times. We're going to be using this a lot, so this is very important to remember, to memorize it. Tangent theta equal to sine over cosine. Now look at on this side, we have cotangent equal to x over y. The same thing here. Cotangent theta is x equal to y, but x is represented by cosine theta, and tangent y is represented by sine theta. So cotangent is cosine over sine, okay? Cosine theta over sine theta. Now there are more quotient identities we can do. For example, tangent is related to secant and cosecant as a ratio as well. Cotangent is related to secant as cosecant as a ratio as well. But they are not as important to remember. But you can actually see, because sine and cosecant are reciprocals, right? Cosine and secant are reciprocals. So if I say and cotangent and tangent are reciprocals, so that's why cotangent is the reciprocal of sine over cosine, which is cosine over sine. All right. And if we want to do cotangent, you see, tangent would be secant over cosecant, because that's the reciprocal of cosine. Reciprocal sine is cosecant, reciprocal sine is secant. So tangent can be written as secant over cosecant, and then cotangent can be written as cosecant over secant. But those are a little bit less useful because you can derive them from here. Okay, so they're using the reciprocal identity, so we're not gonna have to write them. The most important quotient identities you have to remember is tangent equal to sine over cosine. That's the most important, and the reciprocal tangent, which is cotangent, is cosine over sine. Okay, so those are the very fundamental basic identities. Now let's go ahead and take a look at the next set of identities. So let me show you how the next set of identities come about. Okay, as you remember, we are dealing with an angle, dealing with a radius. So let's say our radius is here, and our angle theta is here. This is r, right? And then we have our y segments down here, and our x segment is here. Okay, so I'm just going to use angle in first quadrant. So this is y and this is x, and so definitely they form a right triangle, right? And in any three sides, the right triangle always have a relationship between their sides. In this case, it's simply the Pythagorean theorem. So we know this is x squared plus y squared is equal to r squared. Okay, x squared plus y squared is equal to r squared. And when r is equal to 1, when in the special case when r is equal to 1, in r we can actually divide both sides by r. So let me go ahead and write down the Pythagorean theorem here. Alright, so the Pythagorean, it's called the Pythagorean identity. Okay. But let me show you what happens. So we have x squared plus y squared equal to r squared. So we can divide all three sides by r as long as r is not equal to 0. Well, so that means x squared over r squared plus y squared over r squared equal to 1. But what is x squared over r squared? Well, x squared over r squared is simply x over r squared. And what's y over r? Y over r squared, okay? But x over r and y over r represents what? Our cosine and sine function. So this means cosine squared plus sine squared theta equal to 1. Now notice I write the square, the second power term between the cosine and the theta, because this is to avoid confusions. Okay, so this cosine squared theta, what does that mean? This means cosine theta times cosine theta. Okay, if somebody write like cosine theta second power, this probably means cosine theta times theta. Okay, so as you can see, those two things are different. So Please pay attention to the notations. When we do cosine squared theta, it means cosine theta times cosine theta. It means cosine theta to the second power. But if you write cosine theta squared, this means we're squaring the theta, not the cosine function. Okay, so got to pay attention. So we use this formula. So this is the most basic Pythagorean identity that we will ever use, where you always use this. Cosine squared theta plus sine squared theta is equal to 1. This is the most important thing that we will ever use. Okay, so there are 3 sets of Pythagorean relationships. Okay, there are 3 sets of Pythagorean relationships. So let's go ahead and show you this second one. So let's go ahead and start with the Pythagorean identity again. Okay, I'm going to start with the Pythagorean identity. So x squared plus y squared equal to r squared, which comes from this right triangle. Okay, and let me pull back up just so you can see again. So it comes from this right triangle. Okay, the relationship between the x side, the y side, and the r side. So this time, let's divide everything by x. Okay, let's divide everything by x. So divide this by x squared, divide this by x squared, divide this by x squared. So this will become 1 plus y over x quantity squared equal to r over x. My r is a little bit ugly, I'm sorry. Squared. Okay. Now, what is y over x? Y over x is tangent. So it's tangent squared theta equal to r over x. What's r over x? It's secant. Secant squared theta. So this is another powerful identities that we are going to be used for a lot of times. This is 1 plus tangent squared theta equal to secant squared theta. Okay, now I think you know probably what we're going to do. There's another one we can do. There's another identity that we can come up with using the Pythagorean theorem. We divided by everything by r. We divide everything by x. Now we're going to divide everything by y. Okay, y squared. So let's divide everything by y squared. As long as y squared is not equal to 0, we can divide by y squared. Okay, so this becomes x over y quantity squared plus 1 equal to r over y quantity squared. So x over y is cotangent. So it's cotangent squared theta plus 1 equal to cosecant. This is cosecant squared theta. So now we have all 3 of our Pythagorean identities. Okay, all 3 of our Pythagorean identities. 1 plus cotangent squared theta equal to cosecant squared theta. Now, we have 3 to start with, so let me go ahead and write them on the same place. So we have our Pythagorean identity here. We have 3 to start with. But we actually have a little bit more than 3 to work with. I'm going to show you why. Because each one can be written in different formats. Alright, so this is going to be the way that we write them. So this is just keep the pattern, keep the format. So we're going to be writing them like this. Sine squared theta plus cosine squared theta equal to 1. 1 plus tangent squared theta equal to secant squared theta. And 1 plus cotangent squared theta equal to cosecant squared theta. Okay? But we can arrange them differently. For example, let's take sine squared theta plus cosine squared theta equal to 1. So in this identity, we can solve a cosine squared theta. So what's cosine squared theta? Well, cosine squared theta is 1 minus sine squared theta. You see that? I simply subtract sine squared theta from both sides. Conversely, by the same token, sine squared theta is 1 minus cosine squared theta. So out of this one equation, I can actually have at least 3 basic equations. I can solve for sine squared theta in terms of 1 and cosine squared theta, which is this. I can solve for cosine squared theta in terms of 1 and sine squared theta. And I can do other things as well. I can even take square root on both sides. So cosine theta is equal to square root plus minus 1 minus sine of square theta. So this is a further extension of things that we can do to every one of them. Okay, so when you look at the Pythagorean identities, you need to be able to remember that it's not just 3 equations here. They're not just equations, they're identities. That means they're equations and they're true, and so we can manipulate them, we can move them around. We can solve for tangent squared theta here, we can solve for cotangent squared theta, we can solve for I can put tangent squared theta and together secant squared theta minus tangent squared theta equal to to 1. Okay, I can do cosecant squared theta minus cotangent squared theta equal to 1. So there's a lot of varieties that we can come up with by moving them. So I don't have to. Now I don't think I want to write them all of them now for you, because that would be a little too much, but this is something that I definitely need to mention, and then you need to keep in mind that you can move them around. You don't have to just stick with the 3 equations like that. There's definitely things that we can move them around. Okay, now let's go ahead and take a look at some other basic identities, I think. Now we have mentioned the even and odd functions already, so let's go ahead and talk about even and odd function again. So we have the odd functions. We have the odd functions and we have the even functions. And so when you have the odd functions, when you have opposite, so odd functions, since sine is equal, sine is an odd function, so sine of negative x is equal to negative sine x. So that's something we have talked about before. I just want to make a brief mention. They're not really part of this identity. Well, they can be considered identities, but let's go ahead and do that. Sine, cosecant follows sine, and okay, and secant follows cosine because both of them are even. Alright, so cosecant of negative x is the same as secant x, and tangent is odd also, so tangent of negative x is equal to negative tangent x, and cotangent is also odd. It follows tangent, so it's negative cotangent. Alright. Alright, so those is the odd even functions. I mean, we can use the cofunction also. I think we did a little bit of that before, so by using the 180 degrees minus theta and things like that. So those are also possibilities that we can use, but I'm not going to go ahead and dwell too much on that right now. Okay, alright, so we're going to go ahead and practice some of these things. We're going to see how we can use this to simplify trigonometry expressions starting next lesson. If you have any questions, if you're not sure on something that we talked about today or in previous lessons, please leave questions in the comment sections. Thank you, and then we'll hopefully see you join us in the next lesson.